Welcome back to the logo forming project. In this part, we're going to look at exploding particles off of our shape and then reversing that sim to make it look like it's forming from a kind of a nebulous cloud of particles. So there are actually quite a few ways that we can go about exploding particles off geometry. So first off, let's actually start creating some particles to emit off our geometry, which we've done before. I'm actually starting with a fresh scene here, and I think we're going to actually use the reveal type logo because it's kind of it's got a bit more interesting sort of topology to it, and it's going to be important in a second when I introduce you to flow fields. So first off, let's create a system. Let's do system, and we can actually delete the emitter that's in there. And what I'm probably going to do is I'm probably going to create a connect like I usually do to make it easy to organize our emission geometry, and in case we want to add any more later on. So I'm just going to, whilst holding Alt or Option down and I've got my reveal type, I'm going to add a connect. I'm going to turn welding off this connect. It just helps performance. If I added loads more polys, it would just stop things from welding together, causing weird geometry. And let's just call this emission geometry. Now we're going to be doing this a lot in all of these projects. You'd be very familiar with it probably if you've used X-Particles much. So emission geometry, we've got our reveal type is now our source geometry. We could actually hide it for now. And then we want to emit off this geometry. So we can use that command that is in the quick tools. So we've got the quick tools up here. You could dock these icons, but you just hit emit from object and it reports successful emitter creation. Let's put that in there as a child just to organize it. Press play. Now particles are coming out, but they're very small. There are dots in the viewport, so I'm just going to change them to squares. And let's change a couple of things. Let's do way more particles. There we go. And as you'll realize, that is actually exploding off of our geometry, and we could use this as our method. So if I just have it emitting at the very first frame and then they kind of die off, but then that's kind of hard. If you imagine that in reverse, that's not going to be very useful to us. In fact, there's a modifier called xpRewind, or xpHistory I should say actually. And if I just demonstrate what that does, I can have it reverse the playback, so it stores it and then keeps bouncing back and forward. Now at the end of the playback, you can have it freeze, so I could add an action. I'm just demoing this quickly, don't worry, this is not for the project, this is just to show you some different techniques and you don't need to follow along necessarily. So there we go, we could have it come back, but there's all sorts of problems with that. You can see it only freezes that first frame where the particles are already moving and such things like that. So that's not going to be very practical for us, although that history mod is pretty cool. Definitely recommend playing around with that. But what we want to do is we actually want to set the speed to 0, so they're just emitting and then they're on there. And we don't want to emit it over a certain number of frames. I actually just want to fire it on the first frame and then we're done. So I'm going to fire shot and let's make that 20,000 particles. And there we go. And depending on the size of your particles, you'll need more to cover the shape, or it completely depends on your scenario. One thing I'm going to do is I'm just going to turn off our system icon in the viewport. I'm also going to tell it to use only the modifiers in the same system. If you remember, that just helps us keep separate systems isolated from each other. And that's going to become very important in the next video as well. So, okay, we've got our system. I'm actually going to call this, I'm going to name this now. It's going to be called the Implosion. And this is what's going to have this nebula of particles and they're going to form. Okay, so like I said, you might need more particles to cover your shape, depending on the size of them and that kind of stuff. We're going to have ours very small. We'll start to deal with the radius and stuff a little bit later on. But for now, there's a couple of other techniques that we could use to explode particles off here. We could use an attractor. So say we go into our motion modifiers, attractor. Now, obviously that sounds counterintuitive. We are attracting it to the logo, but we want to explode it or, expel them from it basically. So, but what we can do is we can have an inverse on the attractor. So if I press play, you can see that explodes away. The only problem with this is that this is not using the geometry or any kind of It's not using the normals of the geometry, so it's just exploding out or pushing away from that center point. And we could use force mode, and that blends better with sort of turbulences and stuff, and we could definitely get a cool looking effect. But it's all from the center point, and that's not what I want. Just to show you the last one of those that I can think of off the top of my head, just because it's worth knowing that these things exist, there is an explode modifier. Now this is really cool. It does explode it out of the particle mass center, so it looks for the whole set of particles and then will explode out from the center. Now this just so happens is that the center of mass of this reveal logo is the center of its polygons, so it looks very similar to the Attractor. We could have some variation in that, so it kind of doesn't all blow up at the same time. We could have it constantly exploding, so that becomes more like an Attractor. And we could also have it move away from the modifier itself. Okay, but like I said, I like to show you a few things, a few different ways of doing something first before I jump to the actual one that we're going to really explore. And this is a really cool object or modifier in X-Particles, and it's under the dynamics modifiers. And what we do is we're going to add one. It's called an xpFlowField. And what this does is this, well, let's do some demonstrating this. It's much easier to demonstrate these things and then talk about them. So we want it to cover our logo enough. So I'm going to probably have it so big, or I might round up some numbers here. So let's just have a look at the front. Oh, it doesn't need to be quite as large as that. Let's do 600. And it doesn't need to be as deep as that. So I just want it to cover enough of this, and you'll see why this is useful in a bit. But for now, let's just demonstrate what the flow field itself does. And you can see, if you look closely, there's these arrows. Let me just hide the grid, actually, of the scene. So filter, grid. I like to get rid of the world axis. I can leave horizon on now. That's fine. Okay, so you can see, if we look, there's just this 3D voxel grid of arrows. And these arrows are actually velocity vectors. It's a direction for the particles to move in. Now, like I said, if I press play, you can see they're not moving at all. And the reason for this is that the default mode for the flow field is just to set a particle direction. But if I change the mode from field mode from direction to velocity, and I press play, you'll see the particles move off the surface and away from the geometry. Now, did you see there was a little moment where they kind of expand out? Well, that's probably because we've only got the strength set to 10%. If I set it to 100%, it'll be quite strict, and it'll force the particles to move through those fields at 100% strength. The strength slider just allows you to sort of blend these velocities together a little bit. Okay, so I shouldn't say velocities, I should say vectors, because they are. So that's that's the default mode. It just fires them off in the Z direction. And that's pretty uninteresting. That's just the default flow. If I put it to random, you see the arrows point in all different directions. And when I press play, we get a much more interesting looking particle motion. And if I change the particle display type to lines, actually, that'll help us see their motion. And why don't we just set some color stuff up? Let's do gradient by parameter. Let's choose an interesting gradient. Maybe just use the heat gradient for now. It's one of the defaults. And we could just do it by speed, because that looks kind of interesting. So, or actually it might be better to do direction. Let's see. Oh yeah, because they're all the same speed in that in that zone. So let's do direction, and let's just do heading. It'll just look a bit more interesting. There we go. Cool. So we've got particles flinging off all over the place. And if I actually, instead of lines, use arrows. Oh, and and the particles, you can see they're not oriented with the flow, so we need to go to the Extended Data tab, use rotation, and set to tangential. That's all off by default for performance, because sometimes you just need the dot particles. And in fact, we'll turn this off because we don't need this to be aligned. But you can see, if you look at the arrows of the particles, the blue ones, hopefully that's visible enough, you can go to the flow field display tab and you can turn the transparency off a bit there. You can see that they start to align with the arrows of the velocity fields. And you'll see as they move into them is when they start changing. So like if they move too fast through them, they're not going to have any impact. But if I go back to the general tab and put that velocity up to 100%, this might be a bit wild here. So there we go. It's a bit crazy, but that means they'll conform to those arrows much more strictly, to those velocity vectors. Okay, so let's reset some of the stuff on our emitter. We won't use rotation for now. On our display, we'll just go to the lines. There we go. And that's that. Okay, so we've got this velocity field, but we're not really doing anything with the logo. We're just starting the emission on the logo, and then away they go. They move off and they're pushed away with velocity. Let's go back to that. Let's go back to sort of 20% or something like that on the velocity. There we go. And display tab, we'll put that back to 80%, so it's nice and faint. Okay, so yeah, like I said, it's not based off the geometry. Only at the beginning is it based off the geometry. And it's kind of a bit wild. It kind of sticks to it and ends up there. Well, we can actually use the geometry itself to give these particles motion. And this is where it gets really cool. So if I go to the General tab, let's go to frame 0, and I go to Surface Normal, I can add our geometry, and I'll just add our Emission Geometry because that's the one I want to use. And you see immediately the velocity vectors change. And we get these blue ones and then these slightly different colored ones closer to the actual logo. If I go to the Display tab, and I actually uncheck this direction only, and that means that our vectors are scaling visibly in the viewport based on the strength of the fall off. So if we go back to General, you can see we have this fall off distance, and this is the fall off from the surface that you've just assigned, the object. Let's increase that actually, let's do 100. And one thing to note, if I press play, you start to see they move off. And they've got this kind of nice motion away from the surface. So that's pretty cool. Currently, they're all going off at the same rate, so you get this nice sphere. I mean, that looks kind of almost worldly, like a world map or something, quite interesting. But what we want to do is I might drop that back to 10% actually. A bit slower. There we go. There are other modes as well. There's Tangential Mode, so we could change it to Surface Tangent. Now this one will move kind of, if the normal of in fact, let's take a look at the object. If I turn our geometry off and I just go to our polygons, turn our SDF off, go into Polygon Mode. Now in the display, in the options, we're able to see Polygon Normals. So if I turn those on, you can see, and I select everything. This is what the flow field is looking at when it's creating this velocity vector. So if I turn this all back on, you'll see the flow field's created. And currently it's a very low resolution flow field. So this cell size, as I reduce it down, you'll see it becomes much finer in grid. I don't want to go too fine, otherwise it would be a bit heavy. But you can see the arrows are relative to the geometry. They're kind of following around depending on the topology. And because this is tangential, if I go back to normal, there we go. Normal will push away from the geometry. And depending on which one's closer, it's gonna blend the velocities. Okay, so let's see about that with a much finer, there we go. And if I continuously emit, so if I go to a rate emission, emit in all frames was unchecked. There we go. You can kind of get a better idea of the flow away from it. And so this is relative to the shape that you put in here. And if I drop the logo in, so if I swap out and I hide that one and I put this one in, you can see it switch to the logo. And there you go. You can start to see that's flowing off the logo. That looks pretty cool. But I think we'll go back to our reveal type. Keeping that nice and procedural. Okay, so this is the basis of our exploding off our geometry. This is what's going to drive pretty much all the rest of the motion of these particles off of our object. And that's a pretty simple thing, to set up. You add a flow field, you change it to surface normal mode, assign it the emission geometry or the geometry you want, make sure the bounds are including it. You can also animate the geometry through if I move this, watch this. So if I move this is active. So that's pretty cool. So you could have animated geometry, no problem. But if the animated geometry obviously leaves the zone here, it's not going to have any velocity vectors. So you can see I have to push it back in before it comes off it again. And you can create some really dynamic, really cool effects with this. But yeah, back to the methods. We change it to velocity mode to make sure it's actively giving it velocity. If I switch it, now we understand what that mode does a little bit more. If I change it back to direction only, and I go to our emitter, and I actually give it some speed, and press play, you'll see that is then when the direction is useful. So it's not adding any velocity to the particles, it's just directing them where to go. Okay. But let's go back to our shot emission. You can see actually the particles, it's quite interesting, because they're not moving and they're in direction mode, the particles are actually coloured by the heading, their direction, so they actually blend at the beginning there. It looks quite cool. We're not going to be using that, but that's just an interesting one to play with. Okay, so what's next? So we've created this explosion off here, but like I said, it's very I need to change it back to velocity. There we go. It's very ordered. So when I play it for a little while, zoom out, we've got this perfect sphere because, well, not quite a perfect sphere, but essentially all the particles are at the same rate. So there's a few ways we could limit the particle speed, or we could, add a fall off to make sure it doesn't sort of hit in certain areas. But I'm actually going to be using a fall off in a bit to activate this. So I'm going to bring in a sphere field, and I'm going to actually animate it through this flow field to actually activate it. So what I'm going to do is I'm actually going to use mapping inside the flow field. Just like all the other modifiers, you can use mapping in a flow field. And the parameter we're going to drive is actually strength. So if I go to our mapping tab, let's add a map. Now, by default, the strength is the correct one that's being driven. I press play. All that's going to do is increase the strength or multiply the strength over age, and over age between 0 and 90 frames. So it's going to get stronger and stronger as it goes. But that's kind of irrelevant because obviously they've left the flow field long before they hit this 90 frames. So in reality, it's probably over the first 10 frames. There we go. You get that bit of acceleration. Now, I don't want that. I want to simply create a kind of a noisier, more random explosion off the surface. So first off, let's change this to a noise. And what I'm going to do is I'm going to add a shader map. I'm going to use particle position, and I'm going to add a noise into this shader here. So I'm going to add a C4D noise into this shader here. Now, if I press play now, it won't be very perceptible what's going on. In fact, I'll tell you what I'm going to do is I'm going to just change our display to, well, I'm going to give it a single color display, and I'm just going to emit way more particles. So let's do 100,000 to start with. Oh, that's quite slow. There we go. Just want to be able to display it quite quickly. So let's do squares. There we go. Okay, so we're kind of getting an idea of the density of stuff here. Right, so jump back to our flow field. Currently, our noise is being mapped to this noise, if you like, but the scale of the noise is really, really, really very small relative to this particle system. So we actually need to pump the size of this. This is just a quirk of the mapping system. Pump it up several tens of thousands of size, and I'm just going to give it some serious contrast as well. If I drop the size back down to 100, you can see you can dial in your contrast there, and then scale it back up again. Press play now, and if you look at the very beginning there, we're starting to get a much more randomized set of particles, and in fact, some of them don't even get activated at all, and we're left with this noise imprint of our logo. Now that's pretty cool. But what I want it to do is I actually want it to all vanish at some point. So I want it to kind of eventually all be removed from the scene. So I could change the contrast settings here. I could have, less contrast and it would, let's just do that. So if I do less contrast, more particles will be included because more of this value is going to be white. And when we're talking about mapping, I've explained this a little bit before, but the mapping is just multiplying whatever the the map 2 value is, so like shaders, times, that kind of stuff, onto this value. So it's multiplying. If you think of white as 1 and black as 0, anything that's pure white will multiply this value, strength, happens to be a 10% value, by that color value or that brightness value. So if I have the noise all white or very low contrast, all the particles will eventually get included. But I don't want that. I want it to kind of break apart. So what I could do is I could animate the noise. So if I just put the animate into 1, you'll see it'll start moving and it'll start breaking apart and give it this much more natural movement away from our logo. There we go. And then eventually everything's captured and all the particles are moving away. And you can see our nebula is much more sparse. It's sort of distributed much better now. We're going to probably go further and tweak that even more. But that is the principal idea behind creating our nebula. We've got our flow field. We are mapping the strength of our flow field to a noise. And now we're going to activate the flow field or activate the animation using a fall off, a field. So what we can do is we go to the fall off tab. And here we have the fields, and these were added in Cinema 4D R20. So if you're in an older version, you'll need to use fall-offs. And we've done an explainer video of exactly how to do that in the bonus video section. So check that out if you need to. But since we're in R20, we're going to use a spherical field. This field's going to be kind of quite large. Let's say 250. 230, about the same size as the height of that, but it needs to obviously be, well, it doesn't have to be. I'm going to animate it in from one side. Let's put auto keyframing on. Now that's a bit of a dangerous parameter sometimes, but I think you'll be fine with it. Scrub along. Maybe just do it to like 120 frames. We'll probably retime this when it comes to the actual sim. And I see what, I'm going to make it, yes, that's not going to cover, you see the inner part here? That's not going to cover the reveal. So what we could do, turn the auto keyframing off, go to the coords tab and actually scale it up in one axis. In fact, let's just try double. Yeah, that's fine. And I can get rid of those keyframes because we're not actually scaling. And now if I press play, you'll see the particles stay in position. But then as I bring the field, the fall off into the area of where the flow field is active, it actually activates it. We'll probably have this much slower. In fact, let's just do that now. I'm going to make that probably double. Let's go to 220 on that one. There we go. Kind of captures it much, much steadier. And it might be worth actually having some linear keyframes on that one. I don't know if it's... It doesn't need the gradual start because the graduation in how many particles are included is sort of built into the fall off itself. And what I might do is I might increase the fields. If you jump into the field tab and we can actually have a look at the remapping tab. This is like a contrast for the field. So you can think of it a little bit like that. So I just need to up this a bit and you can see the inner fall off is so everything within this is like 100%, and everything out is softer. So there we go. Then it just activates it all a bit quicker. We get this messy, awesome looking nebula coming out at us. If we zoom out, we can see it just keeps on going, and well, it could extend the timeline. In fact, let's do that now. Give it a few more frames, and it keeps on going. But we don't want it to keep on going because if you think about this, we're going to reverse this whole simulation. So we've got to keep that in mind. So this is the actual end of the simulation. We want the particles to be sat on our logo, having revealed it. And then we're reversing this moment. And we could prototype it using that history modifier. But for now, I think we'll just stick with caching. But you can see as it explodes away, it currently kind of just keeps a constant speed once it's left that sort of area. What I want it to do in reality is from this point is to start pretty much static or close to frozen and then start to accelerate in towards our logo. So what we need to think about is, what is acceleration in reverse? It's deceleration. So we're going to use a speed modifier. So a motion modifier, xp speed. And if I go to object, I'm going to change the mode from the operational mode from incremental to acceleration. And then just like the attractor modifier, if we use a negative value, let's go crazy. Let's use a negative 20 to start with. This should decelerate the particles. In fact, that's way too aggressive, you can see. But the principle is there. That is exactly what I want it to do. Just depends on how high your exponential value is. Let's go for 10. And this is obviously dependent on how, well, this will dictate how far out our particles actually get. So again, that's still a little high. There we go, spreading out nicely here. I think once we add some, I'm going to add some noise variation into this value as well, so they don't all just stop at exactly the same time as each other, because it kind of looks a bit weird. Again, we're just applying this deceleration all at the same rate on all of the particles. So to give it that natural breakup, that natural variation, we can use exactly the same technique with the mapping that we did with the flow field. So if we jump into that noise, into that flow field, go to the mapping tab, we can actually just copy this noise because it's going to be pretty much the same. In fact, maybe it's easier to just go with that. Copy shader, go to our XP speed. We're going to add a new map. Default in this particular modifier is set to exponential. And if we go to that tab, that is the value that we're going to multiply. So it's this -7 value multiplied by the shader. And I paste this into the shader tab here, and I don't think we're going to change anything in this. Probably at the right scale. And it might look quite interesting that the first particles to get accelerated might get decelerated at the same rate. So let's just test that out. Go to the object tab. Mapping. Not unique random, we need it to be particle position. Unique random just looks over the whole surface of that shader, you know, black and white shader, and just goes randomly assigning particles colors from that, or values from that map. So we don't want that. We want it to be particle position, so not random, not UVs, particle position, because then that's like a 3D noise. You can think of it as like the particles moving through a 3D noise scape. And in fact, we're going to come and apply some color using that technique in a bit. But for now, I think that's pretty much set up. And if we press play, in fact, this is probably a good time to change the emitter display to speed, because then we'll actually see deceleration. So gradient parameter, I'll just leave it on that for now. And then let's do speed. And then I'm just going to have it automatically decide what the minimum and maximum is. So minimum obviously is 0 at the moment. And there we go, they accelerate away. And then the deceleration is occurring. And the blue ones now form. And you start to see this forms a lovely looking sparse explosive nebula. And that's actually probably happening a little too soon. I probably want it to come out even more, depending on the camera. I mean, we'll tweak all of this when we actually have this in a scene together with our other elements. We're bringing in some trail elements and some other sort of small bits and bobs. But the main deal here is just that we're exploding them off here. I think I want them to happen. I want the deceleration to not be at the very beginning. So I want it to start a little later. We can use questions and actions for this. We can actually check what the particle, how far they've traveled, how old the particle is, and then activate the speed modifier. So it's not quite the same as mapping. Mapping is sort of a gradual based remapping data from the particles, or, you know, on other input data. Whereas a question, and if we jump to our emitter, add a question, this tests the particles at any one point and says, are you greater than this age, or are you matching these parameters, this question? If so, return a true or false value and activate something based on that. So it's more of a sort of a spontaneous control thing. It asks the question, if it verifies that it's active, drive this action. So currently it's set to particle age is greater than, and let's use that as the demonstration. And what we're going to have it do, instead of driving an action, we're going to have it activate a modifier. And if you look here, if I just collapse these down, you can see here we've got this activate or deactivate modifiers. And if I drag our speed in here, the icon of the speed changes, and that means that it's a action controlled modifier. And if we actually select that, go to the object tab, you can see the mode, which is in every single modifier, is either independent, which means it will just constantly activate on the particles based on the mapping and whatever the modifier has. And then action controlled is waiting to be triggered or waiting to be deactivated by a question or some other input. So currently it's set to, if the age is greater than 90 frames, activate the speed modifier. So we want it to come in. I'm probably going to do this by distance actually. So if I drop a sphere in here, this kind of gives us an idea. I want it to kind of start decelerating once they've kind of got out a little bit further. So I like to drop guide geometry in occasionally. So I've dropped a sphere in here very temporarily just to gauge a rough size of or distance that I want the particles to have traveled. So this is just a guide, but 150 looks about right. So they've just kind of left the flow field. That's when they're going to start decelerating. So I can get rid of that sphere. Now I know the value. I'm going to change the particle data from that to particle position. And then if you look here, the default is it's the distance along spline. That's more for when you're using a follow spline modifier or something similar. And then there's literally just this one here, very simple, distance traveled. And that is literally the distance the particle has traveled since it was born. So the recorded distance, local to the particle, correct. The mode is greater than. In fact, I think that is pretty much what we're going to use, is greater than 150. Is that the default? That is coincidental and brilliant. So it is 150. You can input any value depending on the size of your logo. And now when we press play, in fact, the particles should get out much further than they were initially. So it's a bit hard to see if this is actually doing anything. But what we could do is we could force it to change the display of the particles. So we could have it have an action as well as a modifier. And it could change the display of the particles, maybe to lines or something. It probably won't change the color because this is a gradient. But you can see as they travel out beyond their 150, they switch to that display, which means they are being activated. Excellent. Now that display is a little bit slower, so we're going to turn that off. Go back, press play again. And there we go. And we're getting that deceleration starting at the 150 units traveled. And then we get this much larger sort of nebula, or somewhat larger nebula. I can get rid of that action. And like I said, we're going to be combining this with other things in the scene. So this won't be our final shape, but this is just the principles of it in here. Now I mentioned something earlier about color. And if you consider that we're reversing this simulation, this is going to be the starting color. And when you're reversing a cache or reversing a simulation, it might be quite tricky to apply color to this nebula. So what we can do is we can actually have sort of an inheritance setup, and we were using the inheritance mod in the last video. But what we could do is once we're on the last frame of the simulation, and if I change our animation mode, play mode to simple, and I let it play to the last frame, I mean, they're already pretty much stopped. What I could do is I could actually duplicate this emitter, like so. If I turn that other one off, and we call this, color driver, I guess, it's going to be what the other emitter is going to inherit the color from. So what we could do is we could go to the initial state tab and hit set initial. Now, when I go back here and I press play, you'll see our particles are now in their end state. And this is like one step towards creating an inheritance system that we can transfer color from one emitter to the other. In fact, actually, I should undo this step. Let's clear this state and press play again, and you'll see it just goes back to being an emitter where it changes like that. And we'll apply some color right at the end. And that's actually what we're going to be doing. It doesn't have to be right at the end, but the reason for this is that we want some 3D noise going out throughout our nebula that we can use later for rendering. But I just wanted to demonstrate this early on so that we're familiar with this concept. So I'm going to add an XP Color modifier. So we go to Modifiers, Control Modifiers, XP Color. It's a very popular mod, obviously. Use it quite a lot. And let's just add a shader. So let's do another noise. In fact, we could paste that other noise in because it's already at scale. So if we paste... Oh, I didn't mean to do that, actually. Object. Oh, we don't have it in our memory, in our clipboard. That doesn't matter. Let's just change it up to that 30,000 value. And now let's clamp it quite strictly like the other one was, but let's not animate it. So if I press play now... oh, this is another thing to note, is that if you have a gradient display mode, the XP color cannot take it over. So it needs to be a single color. We could just make it black, like so. And then the XP color modifier should be able to give it the color. Well, that doesn't look like it's applying. I might be... Let's give it a second, see if I'm missing something here. Is anything else setting its color? No mapping, no nothing. Interesting. I might be off on the scale or something. I'm not 100%. Threshold. Oh, maybe it can do with a smaller... Oh yeah, way smaller. I had my... That particular noise is way, way larger. So this is actually sort of 3D space noise. There we go. And you can see the particles actually moving through this noise. It's quite cool. And there you go. You can see this is the principle of what we're going to do in terms of stamping a color into our particle system at the very end. Now, it doesn't really matter where they are in terms of position, as long as they're at the sort of end frames. I could pause it now. But because I set the play mode to animate play mode simple, it just meant that it stops at the 500th frame. Let's go back to our emitter and let's, in the Object tab, the Initial State tab, hit Set Initial State. And now, in fact, if we turn the color off because it's no longer needed and we press play, our particles are in their final position. Now let's jump back and turn on our other emitter and let's hide our color driver. And if I hit press play now, you'll see it's gone back to the original color. And what we're going to do is we're going to add an xpInherit. And this time with the inherit, we're going to have it inherit just the color. Not the position, nothing like that, just the color. And it's going to be an immediate action. So we need to have it set to immediate mode. And then we need the donor or the target emitter assigned here. The probability is at 100%. That's all correct. The weighting and stuff like that. We don't have any mapping. And then if I jump to here, the parameters, I don't want it to inherit the position. I just want it to inherit the color. So if I press play now, I think we'll probably have to change it from gradient again. Display, single emitter color. I mean, I'll leave it on green, but it should inherit. There we go. So you can see, now the interesting thing here is that this noise is much smaller scale here. And the reason for that is that we've stamped the color on based on this position of the particles. So this is really cool. So if I press play, the particle color is actually assigned to a specific particle all the way through its animation. And we're going to use this later to blend and do all sorts of cool stuff in the rendering. So there we go. And I've turned the color off because I don't want to drive the color of this main emitter. Okay, so that's one thing we've done. Now we want to do the reversal stuff. So we want to reverse this animation. Now I could do this using, like I said, I could use that history modifier, but I like a really controllable way of doing this, and that's using caches. So I'm going to create another object, and it's called xpCache. And we use caches a lot in xParticles. It's a way of caching either to disk or to memory the particle positions and data so that we can scrub the timeline. We know it predictable where they're going to be, and there's no more simulation or processing time used up. So especially good for like heavy sims that take a long time. You want to cache them out and then check them and that kind of thing. For now though, what we're going to do is we're going to cache out the animation of this particular emitter, and then we're going to reverse that cache. So let's do that now. So I'm just going to put it in my default, this is my default location. This is set in your preferences, and you can set it to a network drive as well if you're going to do some team rendering and that kind of stuff. But if I hit build cache, or actually let's just go back to the beginning. I'm going to, before I press build cache, in inclusion, I'm going to exclude, actually let's do include. I'd rather include, that gives me more control. I've changed it to include mode, and I'm going to include just this emitter. Now later on we might want to add more emitters and we might want to include more emitters, but for now let's just do this. So I'm going to build the cache, and I'll let it cache and I'll come back. It shouldn't take too long, but I don't want you to watch this. And then we're going to actually play around with some of the reversal settings. Okay, see you in a second. Okay, so that cached really quickly, and we've got a 1 minute 35 seconds that took. And if I just scrub the timeline now, we actually get our simulation playing back, no problem. And I can scrub to a specific frame, and that is accurate to where it is in a cached position, proper simulated. Okay, excellent. Well, now is the reverse stuff. So if I jump to the XP cache and I go to playback, we actually get a few controls over the sort of timing of our cache. So right now, the scale is at 100%. If I change it to 200%, it's not the physical coordinate scale, it's the time. So that's playing it slower. Sorry, actually that's playing it faster, playing it doubly as fast. So there we go, that's doubly as fast. If I drop it down to like 50%, that's going to be, or 30%, that's much, much slower. As you can see, the particles don't even come in. Now we don't need to, we can turn all this stuff off actually, so all the field stuff. So it doesn't even start until like frame 200 on this one. And if I scrub along, it's not even finished by 500. We'd have to extend the timeline to even see that. But what you can also do with this scale parameter is make it negative. And this is really cool, so, and really powerful as well, actually. So first off, let's make it negative. There we go. And it starts off here, and if I scrub along a little bit until you can see it starts to pick up. And because of the deceleration being a bit more sparse, it's now becoming an acceleration towards the logo. And in it goes until eventually it'll form up at about frame 500. Or a bit before frame 500, I should say. And there we go. So that's really cool. That's actually a neat way of doing it. But we can also offset where it starts the animation. So it's currently ending a little bit early. So, sorry, a little bit late, I should say. I want it to end probably a good couple seconds back. Let's do... And you've got the offset parameter is essentially it's saying where to start playing from. So if you think about it this end, it's going to start playing 57 frames further in. So therefore, because we've reversed it, it's actually going to finish earlier. So there we go. And now we're finishing a good like 3, well, more than that, 4 seconds before the end, which is kind of what I want. All right. So there is something we haven't addressed, and that's actually scale, particle scale. And currently we've got the display set to just squares at the moment, so it's kind of they're all one size in the viewport. I actually want them to sort of scale up as they come into the logo to their final kind of size, whatever that might be. So what I'll probably do is I'll probably have that. We need to reverse that. So in fact, let's empty this cache. So this is something I do a lot. You don't have to empty it. You can always just deactivate it, and you're now back to the normal simulation. But I've turned stuff off here, so I have to turn it back on. There we go. And now we're back simulating playing in the viewport. And if I scrub around, it'll go crazy because scrubbing doesn't, you have to play each frame before the other in X-Particles to get it to properly show. So that's all good. But what we want to do now is I actually want to apply this scaling. So I'm going to have to change the display here to something that represents scale. So I'm going to go display, and I'm going to go for circles. Now this can be a bit of a slower display, but it's worth it because you can see the radius of the particles, and you can see they're much too big at the end there. So I'm going to probably set them to something. Well, let's divide it by 10, maybe even smaller than that. No, that's not too bad. It really depends on, you know, yeah, in fact, let's have a look. As long as you can read your logo nicely, and we're going to be adding some glows and extra elements to this that will probably form it up as well. So that's cool. And I might drop the particle count down. I'm going to drop it by a factor of 10 just whilst I'm testing the scale stuff, and then I'll jump it back up. Let's just play the timeline a bit. There we go. And if I zoom in, you can see they're all the same size. Oops, I just jumped miles back. There we go. And you can zoom in. Now, these are all exactly the same size. It's probably easier to see in an orthographic view, actually. You can see they're all exactly the same size. And we need to change that. So let's add a scale modifier. So it's another control modifier. So we're controlling the scale, or the radius in this case. And in this radius, or in this scale modifier, we're going to have it change the value over time. That's pretty straightforward. But I'm going to have it drop by a very, very low value. So let's start at -0.1. And then I probably want a lower radius limit, actually. So I never want them to go below sort of 30% of their size. So you could just do 0.3 times 0.3. That's probably actually even too low. In fact, 0.2. Let's go 0.2. So if we go 0.2 is the lower limit, so they can shrink quite a lot, but not too much. And then let's add some variation to this as well. It's always good to have some sort of variation. And I'm probably also going to want to activate this modifier a little bit later as well. Now, that is occurring, but I think it's occurring so slowly it's pretty imperceptible to us at the moment. Oh, yeah. It's definitely working. Let's exaggerate this so we can really see it. Let's see. And we could even change the display type of the emitter. So it's not inheriting the color. If I turn the inherit off, change it to gradient parameter, and then we can just do radius, then auto radius. And that, if they're all the same color, we'll know that they're the same size. It looks like they are, actually. Okay. I thought that would have shown a little bit more. Oh, well, we can actually see at the very, very beginning, it is doing it. It's just doing it. I've given it two extreme values. So currently, it's the lower radius limit is so close to this that within one frame, the radius has changed to its target value. So we really need to drop this down. So let's drop it to something really, really low like that. And there we go. We can actually see their radius going down. And if I drop the lower radius limit down, let me increase that a bit more. I could just turn the explosion off as well. You see, there we go. That's our particles fading out to a 0 radius. But like I said, I don't want them to go to 0. I'm going to have them sort of 0.2, but I'm also going to have them slowly kind of gradually get smaller as over time. And I think that's pretty good. I mean, it's a bit extreme at the beginning. And there they go, that kind of fade to their scale. Because I want them to be large enough to read on the final object. So let's, similar to how we have the XP speed activating, let's have this one activated based on a question as well. What I'll probably do is I'll probably do another distance question, but this time it'll only start scaling down further out. So let's or scaling up actually if you think about the reverse. So if we jump to the emitter, the main one, in fact we could actually call this main implosion. Now that's important. I've changed the name of the emitter and there is a cache in the scene. Now something to be aware of is that you should always, if you're trying to load in a cache, it has to be the same name as the cache itself. So for instance, in this case, this cache tag is going to probably look for the original name of that emitter, but it doesn't matter because we're going to recache this anyway. Just something to be aware of. So our main implosion emitter, and we could even give this a different icon color. I like to keep things sort of scene organized. There we go. A bit brighter than that. There we go. So this is our main implosion. And we're going to have it activate with a new question. So we're going to add question. It's currently set to particle age. I'm going to go for distance again. So we need to change this to the question type is a particle position question. And then the distance traveled again. And this time, I think we're going to do double. So let's do 300. And I'm just going to name these. So scale, speed, whichever they're driving. And then in the actual scale question, we just drag our scale into the modifiers to activate. And now these should stay blue until they've moved, or they should stay pretty similar sizes until they've moved away. Oh, I've turned off my flow field. So 300 is probably around about here. And that's when our... Oh, there we go. Can you see them start to scale down? Well, the colour's indicating it for us. As they slow down, they all sort of come to a similar radius, but they should end pretty much on a random size. There we go. Brilliant. If you really want to randomize the sizes, we would need to drive our lower radius limit by a mapping, but in this case, we're not going to need that. That's fine. We can even, in cycles, we can even add randomness to the size later on, so that's fine. Okay, so let's set our emitter back to kind of its initial states. So let's make sure it's got lots of particles. We'll change it to a single color. Remember, it's going to inherit the color of this other modifier. This other emitter. And let's turn our cache back on. But we're actually going to clear the cache. So if I jump back to our main scene, I'm zoomed in a bit there, so let's zoom back out. Always save as well. Just always worth saving. I just had a thought there. Hadn't saved for a while. So if you go to the build tab, and if I hit build now, it'll actually rebuild all of this stuff. I tend to like to empty the cache first. So I empty the cache and then I'll hit build. So I might actually go to like a much larger, actually let's double check the particle count matches. That's good. In the final scene, we'll probably increase this, but for now, let's just press build. And if you recall, we've got this reverse playback stuff. That doesn't matter when we're caching forwards. So as long as the cache isn't active or anything, from another cache even, when you're caching, this playback value it's irrelevant. It only when it's playing back will it apply this scaling and offset. So all we need to do once we've created this cache object is if we make any changes, we just rebuild the cache, and I'm going to hit build cache now. I'm going to hit overwrite, let it cache its frames, and we'll come back and we will see, hopefully, that it reverses in the same timing as we had before. All right, there we go. 1 minute 43. It was actually very quick. And if I scrub along, you'll see that we have this. This is actually more indicative of the final sort of distribution, if you like, because we have our radius displaying. Now, the playback will be slower because of the radius display, but we have an option if we jump into the emitter, even when particles are cached, to override the display. So if we go into the display tab here, we've got this force display option. If I change this to squares and I hit force display, we go back to this, and it's a much quicker playback. So if I just press play, We've got our stamped color that we've inherited from our color driver emitter. And I could have used a fall off. I could draw into that almost, you know, you can imagine having some type stamped into some 3D sort of position particles, that kind of stuff. And it forms a logo. Let's just scrub along a little bit. There we go. And then it comes in the corner there and wraps up. Okay, so this is the principle of using a flow field to explode particles off of geometry and then to cache that out and then reverse that simulation to give the idea or the feel of an implosion where it's coming in and forming our logo. All right, so like I said, we're going to be tweaking this, and this is just sort of, this cache is a bit temporary, and we'll be changing this stuff once we come and bring it back in and combine it with our trail stream kind of objects. All right, but for this video, we're done. So catch you in the next one.